Good afternoon. My name is Carrie Glover and my partner is Ray Ree. Our talk today is about predicting emotion in Facebook messages. So imagine, your best friend posts a message on Facebook about missing his cat. You ignore the sadness in the post and reply with a seemingly playful remark. Your friend lets you know he misses his cat because his cat died. Uh-oh. Yeah, you've made your friend feel worse, and you've made yourself feel guilty. We all know this happens. People post sarcastic messages that are misunderstood. People post rude messages that are intended to be funny. People post mundane messages as though they are exciting. If only Facebook could give us a clue before we post. And maybe Facebook can, and maybe machine learning techniques can help. In fact, Ray and I have done this work already. We started by programmatically gathering 1,000 Facebook messages using a Python script. We then individually labeled each message with up to 6 different emotions. Using additional labels from a friend, we compared the 3 sets of labeled messages and saved only the labels chosen by at least 2 people. The 6 emotions used were love, joy, surprise, anger, sadness, and fear. These emotions have been identified as primary emotions by Dr. Shaver of UC Davis, and similar sets of emotions have been repeatedly used in other emotive analysis projects. We chose this particular set because we felt it most represented the type of emotion in Facebook messages, and because it had been correlated with secondary and tertiary levels of emotions that were available for reference when labeling. Using the Natural Language Toolkit, or NLTK, for Python, we extracted features from our labeled dataset that proved relevant to predicting the emotions in the Facebook messages. Some simple features included question marks and smileys. We also used functionality in NLTK to convert the messages to tokenized word stems for extracting all forms of commonly used emotional words. We totaled the number of words associated with a particular emotion in each message and included the sum as a feature. This helped the classifier take into account all of the emotional words without overfitting the data. The NLTK classifier can make only one prediction at a time. Because our messages are assessed for each of 6 emotions, we needed to create 6 different versions of the dataset and 6 different classifiers. To focus the predictive abilities of the classifiers, we developed specialized feature extraction functionality for each emotion. The result is a separate analysis of each emotion in each message. Consider the message. That's my fave cartoon. I could watch it for hours. The message was labeled with both love and joy. When analyzed for features related to love, we extracted the word fave, short for favorite, and the smiley emoticon. When analyzed for joy, we extracted the exclamations and the smiley emoticon again, because it is relevant to both emotions. After extracting features, we split the dataset into training and testing data, 80% for training and 20% for testing. We then used NLTK to train a naive Bayes classifier with the training data and ran it with our test data to determine the accuracy. Naive Bayes is an AI algorithm that determines the probability for a target label using Bayes' rule. The probability of the target label, given the features, is based on the probability of the target label itself and the probability of the features given the target label. Ray will talk more about our results, but here is a sneak peek at how well the algorithm performed in one of our test scenarios. For each emotion, we tested a dataset with half of the messages labeled with the target emotion and half not. Given 2 possible labels, random classification would result in 50% accuracy. Our results predicted the presence of the target emotion in 80 to 90% of the cases. This equates to predictions that are 30 to 40% better than random. For comparison, we also trained our datasets with the NLTK decision tree classifier. Results from the decision tree were similar but less accurate. Ray is going to discuss more about what we learned from the project and how it is related to AI.
As Carrie mentioned, we each categorized the messages in our dataset according to one or more of the 6 basic emotions we had chosen. We discarded messages when we could not agree on the emotional content for at least one emotion. Once we had our dataset, We examined the messages to find attributes we thought might indicate the presence of a given emotion. We broke out our data sets by emotion and tested our success in 2 different trials. First, we created data sets composed half of messages expressing one key emotion and half unclassified messages. Our goal was to see if our feature selection would help the algorithm outperform random selection. We found our features performed significantly better than random selection on each of the 50/50 data sets, with an average accuracy of 83.5%. After we had completed our trials with 50/50 data sets, we ran the classifier on our entire data set, in each case reserving 20% of the data as test data. We found that feature extraction has a significant impact on results. During our trials, we refined our feature selection as we tested. The results we're presenting today are actually about 10 points higher than the results of our initial tests. Fear and sadness in particular started in the 68 to 75% accuracy range and improved as we removed feature selections. By refining our features, we were able to improve our model's accuracy to over 90% in 5 of our emotion classes, and our average accuracy was nearly 91%. We posit that there were 3 likely factors in these outcomes. First, we were probably overfitting our training data, as we had selected our initial feature set by examining the data. Second, we observed annotator bias in preparing our data sets. Over time, we found that several of our early messages in our review were ordered within threads, and thus we may have unconsciously allowed our understanding of the context to influence our ratings. Messages that should technically have been unclassifiable may have slipped into our annotated data sets. Third, feature selection matters. We started out focused largely on lexical features, counting words whose meanings suggest specific emotions, along with considering emoticons and punctuation. Surprisingly, in our early trials, the classifier reported commas among the most informative features we extracted. We've found, as we've delved into our project, that we've barely scratched the surface of the topic. If we were going to proceed, we'd look to build data sets of messages whose authors have explicitly linked their emotional state to the writing. For example, through indicating their current mood in a status update on Facebook. We'd utilize effective resources like SentiWordNet, which help establish positive or negative connotations of word choices. We'd consider alternative approaches, such as Bag of Words with support vector machines. Finally, we'd adopt an approach taken by the authors of one paper we read. They had built an emotion tree. If a basic emotion was detected, they looked further for clues about whether the text best fit the base emotion or whether the algorithm should proceed to explore the base emotion's child nodes.
The machine learning techniques used in our project are generally considered a branch of AI, and building a machine learning project usually involves several phases, including creation of a labeled dataset, feature extraction, and training of one or more classifiers. We have accomplished each of these phases to come up with the results you have seen here. However, to maximize the validity and performance of our results and to aid in development, we researched and utilized several tools during the project, most notably NLTK, Python, and Facebook developer tools. Thank you for your time. We hope you experienced a positive emotion.